Okay guys, hopefully you tried your best on this practice here. Let's go through and see how we do. 1 and 2, you have to use factoring. So first thing I'm going to do is GCF, which is x squared. And then I'm going to take it out. And then that's going to leave me with 2x squared plus 1x minus 3. And then from there, I have to factor this by using the t-chart. Numbers that multiply to 2, 1 times 2. Numbers that multiply to 3, 1 times 3. 2 times 1 is 2. 1 times 3 is 3. They have to add to a positive 1, so the 3 is positive and the 2 is negative. So this is going to be the minus. This is going to be the plus. Then those are the other factors. So I have x minus 1, 2x plus 3, and then don't forget your GCF. We're going to do that. Now, if you are struggling with the factoring, you need to step up to the plate and come in at nest. Please do. It's not going to go away. You can see that. Now, after our factors, we're going to set each of them equal to 0. So I have x squared equals 0. I have x minus 1 equals 0. And I have 2x plus 3 equals 0. Well, you can see here, guys, this x squared is going to be our double root. Why? Because it's raised to the second power. So yeah, okay, the square root of 0 is 0, but make sure that you remember this is the double root. This is where it's going to bounce off the graph. Here, x is going to equal 1. So this is the single root. There's no exponents here. Here, subtract 3, divide by the 2, so x equals negative 1.5. And again, another single root, because there's no exponents with it. So let's go back and let's now do the graph. We have all of our zeros, so let's do the graph. You can see here this is an even degree, positive LC, so it should be up and up. Always start with your end behavior. Then let's plot the points. We have 0, we have 1, and then you do negative 1, negative 2, so negative 1.5 will be in between. So as you do the graph, guys, here you're going to go through the single point, so there, go through the negative 1.5. When you get to 0, because it said x squared is to the second power, it's a double root, you have to bounce off, and then you have to turn around because we have to end up here. So you turn around and go through that single root. So it should look just something like that. That's the idea. So let's go to example 2, or practice 2. First thing is GCF. Well, there's no number, but they all have an x. Always take out the lowest x, so I'm going to take an x out. And it's going to be x squared minus 4x minus 5. Then I don't have to do the t-chart here because I just have regular x squared. Numbers that add to this and multiply to that are x minus 5 and x plus 1. So this is more simple factoring compared to practice number 1. Bring down your GCF and put it out in front. Now from here, again, after you go into factored form, you set all of your factors equal to 0. So this is just going to be x equals 0, x minus 5 equals 0, and x plus 1 equals 0. When I solve this, I get x equals 5. When I solve this, I get x equals negative 1. So you can see there were no exponents here on any of when I'm solving these roots. I'm not even in factored form, no exponents. So these are all going to be single roots. Which means when I go through them, guys, I'm just going to go through them. I'm not going to bounce. I'm not going to do the weird curve thing, that kind of thing. So let's look at end behavior. This is odd, positive, because it's the leading coefficient of positive 1 and then the degree of 3. So odd positive goes down and then up. Let's plot our points. So x equals 0, x equals 5, 1, 2, 3, 4, 5, and x equals negative 1. So about there. Then, again, you have to go through each point, 1, 2, 3, and you just go through them, guys. So, and you know that this is your end behavior, so you're going to have to turn around here, you're going to have to turn around there. 2 turnaround points has a degree of 3, makes sense. So, you'll get a chance to practice that. Now, the others were already in factored form, so let's go through and see. The nice thing about factored form is you don't have to factor. Just set each of them equal to 0. To get your roots. So this x has to equal 0. This x has to equal 1. this x has to equal -2. Okay? Now, of course, we got to go back to end behavior after we find our roots, or if you do end behavior first, that's fine too. Imagine if we FOIL these out, this would have a degree of 3, because you would multiply there to make the x squared, then you would multiply x squared by that. So this has a degree of 3, so it's odd. And look at the number in front. The LC is a +3. Odd positive, again, goes like this. Got to know your end behavior. So plotting these points, x equals 0, x equals 1, x equals -2. So you have that. Then again, these are all single roots. They're single roots because they just occur once. There's no exponents other than 1 at each spot. So that means you're just going to go through them. So this one looks pretty identical to the last one. Okay, so be careful about that. Look at practice 4. Now practice 4, there is an exponent of 2, so we're going to have to keep that in mind. So let's find the roots. So set each factor equal to 0. So x plus 4 equals 0. And let's solve. Here, if you divide by 3, guys, you get x squared equals 0, and you do the square root. The second you get that, guys, and it was already to the second power, this is our double root. Pay attention to that. It means it's going to bounce at that spot. Okay? It's going to bounce at that spot. Here, when we saw that, x equals 3, x equals -4. So, okay, now let's talk about end behavior. So again, this is 2, and then this is 1, and that's 1. Added together, because if you multiply them, that's the rule, is add the exponents. This would have a degree of 4, which is a positive LC right here, and it's an even degree. So you should be going up and up with your arrows for your end behavior. Then from here, if x equals 0, plot that point. X equals 3, 1, 2, 3, and then 1, 2, 3, 4. Okay? So now let's take a look. These two are single roots. There's no exponents with them, no second power, third power. So meaning, guys, this, you're going to have to be careful of. You're just going to go straight through them. So, okay, I'm going to go through -4. A little off there. But I'm going to have to turn around to touch 0. But when I do that at 0, I'm bouncing. I'm not going through 0. Okay, I'm going to bounce off of it because it's a double root. Then I'll turn around and go through 3. So again, a double root looks like that every time. It's a bounce off. Last practice here, then you can start your homework. Which could probably be the graph? Well, let's again. 1, 2, 3, 4. So this has a degree of 4. And look in front, it's a positive LC. So it cannot be C, it cannot be B, because these are negative end behaviors. Now, the roots would be x equals 2, x equals -4, and this one, like we did on the multiple choice example from the notes, if you solve for the roots, you have to be able to do this. You're going to notice, guys, these are imaginary because you're taking the square root of a negative number. So this would be imaginary 1i, but it comes in pairs. So the only answer it could be here, again, is D, because that would be about the -4. That would be about the 2 single roots. They go straight through them. And this right here, again, when it does a bounce off, represents the imaginary roots. That's the idea. So your homework tonight is just a few problems. It's going to review this, and it's going to review writing the polynomials given the zeros. So you can start on that now.